Right, I'll show you how to answer questions to do with the electromagnetic induction. Now this is foundation level, so there's not much to learn. It's just a little bit about transformers and a little bit about the national grid. So it's actually only worth 5 marks. Question 1. Complete the following sentences using one of the phrases from the box below. Efficiency is reduced, the national grid, a power station, heat loss is reduced, and a transformer. So part 1. Electrical power is generated at a power station. Question 2. Or part 2. Electricity is transmitted over long distances by transmission lines that are part of the national grid. So that's basically the pylons and the wires. You know, you've got your transformers as well. Remember, you've got a step up transformer here and a step down transformer there. Then your power station would be here. Part 3. Electricity is transmitted at high voltages so that... Right, be careful. Efficiency is reduced. No. It's at high voltages so that efficiency is increased. So they've put that there to try to catch you out. Now, remember, if it's at high voltages, it's at low current. And the reason why you want low current is because it's current that makes the wires get hot. Your teacher should have told you high current causes heat, and that's a phenomenon known as line loss. When you lose electrical power or electrical energy in the wires, that's called line loss. So high voltage, we want a low current so that heat loss is reduced. If you're not sure about that, I've got a lovely little video to do with transformers that also covers the national grid. Question 2. In a small transformer, the primary voltage is 230 volts. Right, if you have a little look at this equation down here, the primary voltage is what we call VP. Right, we've got the primary current. Now remember, we use I for current, so I for current, and it's primary, so that'll be IP. And then we've got the secondary voltage, so remember, voltage is V, and if it's the secondary, that must be the VS. So I don't want you to just guess what's what. So there, that's how you know what's what. Okay, right, let's just pop the numbers in. So the primary voltage was 230 volts. Multiply that by the current from the primary, 0.020 amps. And then divide that by the secondary voltage. So VS was just 5 volts. Right, pop that into your calculator, and that should come out as 9.2. And if it's current, that'll be amps, just in case they didn't give you the units next time. Right, and that's that. Short and sweet. Now there are a few other things that you need to know, mind, so I'll give you a quick masterclass. Watch this. You need to know that they make the voltage at the power station is 25 kilovolts. Then what happens is they use a step up transformer, so that makes the voltage step up, which makes the current step down. Now what they'll do is they'll step it up 16 times, and this here will be 400 kilovolts. So 25 times by 16, that's 400 kilovolts. Now remember, they need to step it back down at the end. Now you need to know, if it goes to a large factory, they'll have 33 kilovolts. If it goes to a small factory, it'll be 11 kilovolts. And if it's just a hospital or schools or houses, it'll just be 230 volts. So make sure you know these voltages, just in case they ask you about that. And actually there'd be more step-down transformers here. So if they asked you to label them, remember any transformers at the start will be step-up transformers, and any transformers at the end will be step-down transformers. Hope that helps. Work hard, be nice, and bye for now.